Good morning. Today is September 1st, 2018, and this is the John Chappell
Yes.
Natural Philosophy Society Science Chat. And you can find us at naturalphilosophy.org. You can join us, and you can also join our forums and read information on our wiki. And we can also be found in social media on Facebook. And if you are into Facebook, please like and follow us on Facebook. And you can also subscribe to our YouTube channel. The video recordings of these science chats can be found on YouTube. And if you'd like to help out, we're using something called Basecamp. So if you'd like to help out, send us an email at basecamp@naturalphilosophy.org. Now today, I did announce that we were going to be talking a little bit about gravity anomalies, but Bill Lucas has a presentation on on life being electrodynamic. So I'm going to go ahead and let him do that presentation. So Bill, why don't you take it away then?
Thank you, Franklin. This presentation that I'm giving was prepared for the Vitality Institute in Israel, and they are, of course, interested in the issue of life, and I'm trying to correlate the issue of life, with the universal force. If you really have a universal force, like I was mentioning in the previous talk, then you must have an explanation for life. And it's a little far afield from my field of physics, which I started from. And but anyway, I'll try to give this presentation today and show you some of the issues. In the last half of the 1800s, of the 1800s, many scientists believe that.
You have your slides, Bill?
Pardon?
You have your slides.
Yes. Do you see them on the screen?
No, not yet.
Oh, okay. Let me see. How do I get them?
I've got it. I got it. Oh, it says social media. Is that you, Franklin?
Yeah, that's me. You probably need to click on share, and if you've uploaded your presentation, click on that, but I don't see it. So you have to probably share your screen.
So I'm trying to share my screen. I see it. Let's see if I can do it again.
Hello.
I saw it before. Probably you're just sharing your screen. There you go.
Yes, I'm having a problem with my screen. Internet is slow.
Okay, can you see it now?
Yeah, we can.
Compulsive life.
Yes. Okay, let me go back up to the first. That's the first one. This was the fourth 1-hour presentation I was giving at that conference. There were 5.
So that's showing the the preview. We can see like the file menu and all that.
Yes, this is a note.
I'm going to press like F5 to go into slideshow mode.
Can you go into the slides? I'm in the slideshow on my computer. You can see it on yours?
We can see it, but we can see like the menus and stuff.
Okay, well this is
not full screen.
This is it's not full screen. You can see let me see if I can
Hello.
see if I can get rid of some of the things in the background. They're all showing up.
No, I don't think so. I think we're looking at like the presenter's view rather than the.
Okay, so you want the other one? Okay.
What happens if you click on the slideshow menu that's just up there? Does that start the slideshow?
I can change that so that it's let's see here. Let's see. I want to change that so that the view is the regular presentation. Let's see. From the current slide. So that better now?
Let's see here. Okay, well that's bigger,
Okay.
and it's but unfortunately it's portrait mode, so we can't read the text underneath.
Oh, well, you. If I do that, it gets smaller.
Yeah, I know. So it's kind of I think there's a scaling control or something. Let me see here. It says fit to window. If I click that, let me see if that helps.
Well, I changed the presentation to be just the slides, but I need a second monitor for me to see my notes for what to talk about. But,
well, you can go back to your other view.
I'll
but it's rather small on our screens.
oh, this view is. Let's see.
There's also a gray box at the top right. I don't know if that's your notes. Oh, it's gone. You got rid of it. Thank you. Well, it's gone now.
What do you see this?
Well,
is that any better?
that's a little better. I think that'll probably be fine. I think it's a little small, but we can read it.
Okay.
Everything's in portrait mode, though.
Okay. Well, these are my notes as a speaker, and
I think it's fine. You can go ahead with your presentation.
Okay. The idea that the electrodynamics might be the cause and source of life began in the last part of the 1800s, when Maxwell and others had succeeded in uniting the electric force and the magnetic force and electrodynamics. And this work I have improved on. I mentioned that in the last talk, and I showed that the force of gravity and the force of inertia were also electrodynamic in origin. And then when you do that, you get a better version of the force of gravity than we previously had, and a better version of the force of inertia, and we no longer need dark matter and dark energy. And but that's so. And then I also mentioned that with NIST measuring the mass of the 3,500 nuclear isotopes to 8 significant figures, which was before it had been 3 and 4 significant figures. This enabled scientists to see for the first time that there could not be any strong interaction force or weak interaction force in the nucleus, because if you analyze the mass of all the nuclear isotopes with the same number of supposedly neutrons and protons in the nucleus, they are same total number. They only vary by a 1/r² type force, and the strong interaction force and the weak interaction force are 1/r³ to 1/r⁵. So since there was no evidence for 1/r³ forces, and also when these decay, the binding energy of the neutron does not appear, and the energy is not conserved if you assume there are neutrons in the nucleus. So as a result of that, we get a model which just has the nucleus made of protons and electrons. And then, of course, you have electrons outside the nucleus also. And so that work is in agreement with what people thought in the late 1800s when they were making so much progress with electrodynamics. Now, if you look at the work that's been done in India and China and other parts of the country they also have an electrodynamic view of life. And you can see these images are showing various sources of the electrodynamic current and force inside the body in order to control it. And what is interesting is it doesn't follow the nervous system. And so if you've been familiar with acupuncture and stuff like that, you can control certain electromagnetic forces in the body independent of the nervous system. And that's quite unusual. And we think that everything has to go along those nerves. And so this will try to cover some of that information. As you may know, this shows a picture with someone having the pulses in the brain being measured, and these are EEG sensors, and the brain is thought to control the life in the human body and in living systems, and we have a form of a subject, I guess you say, of bioenergetics, and that's the study of the flow and transformation of energy in and between living organisms, and between living organisms and their environment. And so we are able to measure these things with various instruments, and we can see changes occurring. And one way to tell if a person is dead is to get the electric pulse in the brain, and if it's not there, they're dead. Even though the cells are still alive, but they're going to slowly die over time because they will not be able to continue operating. And there's a physicist named Milo Wolf who claimed that nothing happens in nature without an energy exchange. And so he says this is a rule of nature. And there's coherence among brain waves reflects perception. And an EEG tests can show the pattern among bandwidths, such which ones are dominant and which reflects what is being perceived for one state of consciousness. So if I am taking one of these, monitoring one of these pulses, and I put something in front of your eye and you see it, you can see the change in the pulse because you recognize that, and it forms ideas and things in the brain, and so you can see that there's some kind of consciousness that reflects that. And so we have this certain amount of evidence. We know something about the brain, and certain things about the body are electrodynamic in nature, but how does it really work? The human nervous system connects all the organs of the body through the nerves, and they are controlled by each half of the brain that is assigned to that function. And so this diagram shows how the various organs secrete hormones, enzymes, and digestive juices to control chemical processes in the body. And the electrical impulses are controlling that. And the organs are composed of special cells, and these cells are composed of many different organic molecules. Now, in the nervous system, the communication system of the body, there are various types of neurons, and the communication between the brain and these organs is given in terms of these neurons. And we study this communication uh, by electrical energy, which we call the action potential, in various states of excitation. And as neurons and groups of neurons connect, they form pathways. And if you're familiar with the Berkman type of networks that you see in space, in astronomy, and you can also see it if you have one of these. I have a ball that makes Berkman currents. You can see it split and fork in certain ways. Well, the cell structure for neurons is just like that. It follows the Berkman path. And so there's a lot of things in common with the way the neurons work and electrodynamics. And so we know that there must be an awful lot of the body that is controlled by electrodynamics. And but the nerves are not the only electrical paths in the body. At the heart of acupuncture are meridians or channels that form energetic circuits throughout the body. In this diagram, I identify about a dozen of those paths: the lung meridian, the colon meridian, the stomach meridian, the spleen meridian, the heart meridian, the intestine meridian, the urinary bladder meridian, the triple warmer meridian, the kidney meridian, the gallbladder meridian, the liver meridian. And so we see all of these pathways separate from the nervous system. And so we know something is going on there. But why do we have these separate channels? Why are we passing energy through them? Why don't we do everything through the nervous system? And we also have, of course, the circulatory system with the blood and everything, and chemicals are passed through there, which are secreted by various organs of the body. But the Asians talk about ki, or life energy, and they insert needles into the skin along these channel routes in order to restore and regulate the movement of energy in the body. And this is not just the nervous system, this is these other meridians that's being used. So what we have is this, what I call Asian approach, and the regular nervous system approach, and somehow the two have got to be coherent. And if you look at the foot, for instance, for acupuncture, you discover that in each foot, and actually in your hands too, and in your face, there are places where there are...
Can you enlarge the diagram, please?
I'm sorry, I can't understand what you said.
Can you enlarge the diagram? It is too small to be seen.
Can anyone understand what he said? So
I said that the diagram is too small
can you use
to
the
be seen
chat?
and read.
I'm sorry.
I said,
I think our transmission is not real clear, and we, I don't know if you hang up and call back in if you get a better connection, but we're having trouble understanding, at least I am, what you're saying. But anyway.
Yeah, I'm trying to ask him to use the chat to ask questions.
Yeah.
Because we really can't hear what he's saying.
You know, it could be if he just calls up again to get a better connection. It could be he just has a poor connection. But anyway, each part of the foot has been identified with some part of the body, like the ear or the eye, and by putting needles in that part of the body, you affect that organ. And in the so there's a certain amount of medical practice that uses these techniques to do things versus chemicals and drugs and things of that sort. And they have some validity, because the United Nations recognizes this form of medicine. And so we have more than one approach to understanding things in terms of electrodynamics.
So, Bill, some of this is a little bit small for the diagram here.
Okay,
I think if you went into slideshow mode like you did before, then I think that would be fine, because we'll see the slide in full size, and we don't need to see the notes that are below the picture.
Is that?
Yeah, like that. Let's see here. That's really big, but let's see if that's okay. Yeah, I think that's fine. For people who are watching, there's a control in your lower right-hand corner, and there's like a plus sign, and if you click on that, then it will zoom the picture out to full size, and it looks fine.
I can't. Okay.
But it looks fine to us right now, okay? So go ahead.
All right. So anyway, you can see on this one how many points just in your ear there are that are connected to some other part of the body, and not through what we would call the nervous system directly, but it's going by another path. And and many doctors in America use this as part of their practice in treating their patients. And here's your hand, and on your hand you can see where the various points are. Like, for instance, on the fingers you have the sinus, the head, and the brain area that's connected, and also on your thumb, into your thumb you have that. But down where the fingers are joined into the hand, you have the lung and breast and back, and you have a place where the liver is, and the intestines and kidneys and pancreas, all kinds of parts of the body. And if you injure yourself on one of these spots, it will affect that particular organ of the body. And so a lot of emphasis has been put on that. And so we're seeing more paths, electrical paths in the body than we thought, just looking at the nervous system and following nerves, which have a physical, you can see it under the microscope, you can see a nerve. And also you can see it, if it's a big nerve, in just the naked eye. And but we don't see these other paths the same way. So this is looking at the front of the body, and you see all the different acupuncture points. And I just took these slides off the internet, and you can do that yourself if you want to find more detail. Now, if we look at life in a leaf, and if we look at it with the right tools, we see something that is surprising. Notice the edge of the leaf. There is radiation coming off of the leaf. What is that radiation? Well, people discovered it and they thought that was a mystery. What it was. We now know what it is. It's longitudinal radiation. There's two forms of electromagnetic fields. One is transverse, which is what we're all very familiar with, and the other is longitudinal. But until we learned how to detect longitudinal radiation, it was a mystery, and we saw the solution of Maxwell's equations if you solved all of them simultaneously, but nobody knew what that was. And so when Oliver Heaviside redid Maxwell's work, he got rid of two of the empirical equations of electrodynamics, so he wouldn't have to deal with the longitudinal radiation. And one thing about the longitudinal radiation is it doesn't travel at the speed of light like the transverse do. It travels much faster. Okay, you may be aware that magnetic bracelets, and this is an example of one, can relieve pain, reduce inflammation, and improve your blood circulation just from the magnetic field. Wow. But most doctors say, what? I don't know anything about that. That's crazy. And but there's a certain number of doctors that have discovered it works and they use it. And so we see both the electric field and the magnetic field seem to be able to have a function on the body. The first, one of the first people in America that worked on this was a fellow named Robert Becker. And he's published a book called The Body Electric, but he was working up in Rochester, New York at a hospital for veterans. And he felt terrible when he saw these veterans that had their arms cut off and destroyed and their legs and different things. And he thought, if I do some research, I can help them. And he had heard that lizards, if you cut their leg off, they grow it back. And so he studied them, and he discovered that there was an electrical signal that was given by some part of the lizard, probably the brain, but he doesn't know exactly where. And it comes out, and when a leg is cut off, the cells on the end of the stump of the leg that's still attached to the body, they change the cells from being specialized to a particular bone or flesh or whatever, skin. They cause them to become more universal, like cells, and they start to grow. And he sees them grow, and then as they grow farther away from the body of the lizard, they form this leg, and then they specialize into skin, and they specialize into nerves, into bones, and all this stuff. And after a while, he would never know that the lizard lost a leg. And they study some lizards that normally a lizard has 5 toes, but every once in a while you find one that's a little irregular and has 4 or 6 toes. They cut the leg off there to see what kind of leg would grow back. It was the same type they had. Not going back to 5, but going to 6 or to 4 toes. And so they realized that there's something that is happening in the body that enables us to regrow. So what this man did is he made electrical circuits that he put on the outside of veterans who had lost, let's say, part of their leg. And he got them to regrow their leg. And he found that worked. He found that veterans who had lost part of their arm, he could do the same thing. And so he was doing that. And then, guess what? Somebody wasn't happy with that. And they went to Congress and got the money designated for the Veterans Hospital in Rochester, New York, to no longer support this man's work. Now, thousands of veterans had signed up to get it because they'd heard it works and they wanted it. And the head of the Veterans Administration got some money from somewhere else and continued the work without Congress knowing exactly what was happening. And so he lost his job when they figured out what happened. And then this fella wrote this book to explain what happened there and what we were able to do electrically. And that made the New York Times bestseller because a lot of people were interested in that. And but the Food and Drug Administration, which controls all the medical practices in the country, won't allow this to be used by a doctor without their losing their license to practice medicine. So there's something quite interesting. Becker also wrote an article in a book, I guess, Cross Currents, and he's talking about the promise of electromedicine. He wanted people to know that there's a possibility that we could do a lot with electromagnetic fields. Now, if you look at the cilia on the brain cell, you discover under a microscope that they act like they have antennas, and to coordinate the creation of new brain cells. And so that was interesting to see. And what we find is that, and I can't see my notes, unfortunately, the cells have a way to broadcast a signal into the bloodstream, indicating what they need for food, and then the body produces that in the bloodstream, and they send out little pieces of themselves to capture it and bring it back to the cell. And it's just kind of like they were sending a taxi cab or a bus or something to go get it, or a truck, and to bring it back to them. And people looked at that and they studied it under the microscope, and they just couldn't believe how organized the body is electrically. And there's particular structures of these cilia that you can see here, and if you take a cross section of them, you discover certain symmetries and other properties like that they have. And this is the structure of a primary cilia antenna, and you can see all the detailed structure in here. All of these things each have a specific electromagnetic function, and that took a long time to discover it, to learn how to read it, but it's in the scientific literature. And there is a theory of life called abiogenesis that says that the origin of life is from inorganic matter through thermodynamics and natural chemical processes, and that organic molecules formed by natural chemical processes, and the replication of a molecule is based on spontaneous generation of chemicals, and thermodynamics spontaneously causes metabolic processes. But those theories don't really agree with that. And there's something involved in electrodynamics that's involved in life. Now, this slide shows the Miller and Urey apparatus to generate organic compounds. This is the idea that in the past, the atmosphere of the Earth had certain gases in it. And these gases are shown on the chart. There's carbon and nitrogen and hydrogen and oxygen. And there were electrical lightning flashes and that spark caused the formation of certain molecules. And these molecules went down into the water, and they made a trap so they could keep them and accumulate what we would call, or they called, organic molecules. And these organic molecules are needed for life. One thing that we found out, and they knew that already, people did the experiment, is if you don't make the trap, the lightning that made the molecule destroys it, so that you don't accumulate any net amount of organic material molecules. But that was their theory. And this is the universal force that was derived from electrodynamics. And I'll just go on down here. In different terms or give rise to different types of forces in nature. And we mentioned Bode's law and how you could talk about physical things like the radius of the orbits of the various and the periods of the various planets as they went around the sun. And it also works for moons of the planets. And then the non-radial force terms called spiraling of an odd number of fibers. And this is showing, treating the orbits of the planets like fibers. And you can see here the various orbits of the different moons of Jupiter as they go around the sun. But now we want to look at the structure of DNA. And it also consists of fibers, and they are orbiting around, and they follow the same rules as the planets going around the sun, which is very interesting. Now, these are the pictures that you would see in a biology textbook, but we're going to look and see what we can see now that we know this electrodynamic nature. We can see it in a better way. First of all, this is the shows the pentagonal symmetry. If you would draw a straight line through here, you would have 5 lines going through the center. And according to the laws of electrodynamics, the symmetry of every atom, molecule, elementary particle, etc., has to be chiral. And chiral symmetry means that in terms of lines of symmetry, it has 1, 3, 5, 7, 11, 13, etc. Prime number type things, lines of symmetry. So this has 5. This is DNA. And so now, if we look at the DNA molecule in that form, we can see the 5 different fibers and what they consist of going around as they form the DNA molecule. And so there's a picture of that in the different sub-pieces of the DNA molecules. A certain number of them are sugar and some are bases. Now, if we look at the structure of protein, or collagen, we discover that it has 3 rotating fibers, not 5, 3. So protein is different from other types of molecules in the body, like DNA. And if we look at the structure of starches like amylose and amylopectin, stuff like that, there's really just one fiber that is rotating. So we see how that works. And we only find the groups of 1, 3, 5, 7, etc. in living systems at the molecular level, which shows that the electromagnetic force is definitely controlling it and its symmetry is controlling the symmetry there. And here's glycogen, carbohydrate, and you can see how it's made of a single fiber, but there's 3 of these fibers attached, and you can see how they're attached with these different links marked in red there. Now, if we look at bacteria like Spirilla or Spirochete, we see a single fiber, and it has this fiber rotating type characteristic to it. And now we want to look at the electromagnetic force in terms of the types of wave vibration. There are 2 types. There's the transverse that's shown at the top, and I don't know if you can see this motion, whether it comes through to you very well. And at the bottom you see the longitudinal motion. So they are very different, and longitudinal, by the way, is the same as the sound wave. It's just longitudinal, but sound wave is not transverse, and we find both of them are present in electrodynamics. And now, hospital experiments. We have, I don't think I have, I missed anything. We have developed, I think I may have a picture of it somewhere here, but it's be further down. We have developed a life energy meter. And this life energy meter only measures longitudinal energy from longitudinal electromagnetic waves. And many hospitals now use this meter in the emergency room. And patients, when they come in with tumors and infectious diseases, they have lower life energy readings than well people in just a few seconds. And they don't even have to touch you. The life energy that you're giving off is going right out into space around your body. So you just have to walk by this as you come into the emergency room, and they get a reading of it. And then they can tell from that reading how long you're going to live. Whether you should be number 1 to be treated in the emergency room, or if you're not in great danger, they can just let you take your turn. As if you're the last one in, you're the last one to be treated. And but if you are the last one in that hour and you are going to die soon, and they can see that from your life energy meeting, they should give you priority over other people who are not going to die, and that way they can save more people's lives. They have also in the hospitals had their food service, and they have tested it with the life energy meter, and they have found that food with high life energy readings raises the life energy of a person for a time. They also found that sick patients get well faster eating food with high energy readings. And what they did in the hospitals, they divide their food service up into 2. And they let the patient choose the one they wanted. And then they kept statistics on that patient to find out how they did. And what they did in the 2 versions of their food service, one had the foods with all the high energy, and the other one had the foods with lower energy. But since people don't know about those things, they just thought it was just a choice of one or the other because it's a different kind of food. And so they didn't know what was being done, but they were actually being used for research. Now, the second piece of information we need to know about the origin of the electrodynamic version of life is due to a medical doctor named Anton Prior. Anton Prior was in medical school during World War II when he was drafted to serve in the military, and he served in a radar unit. And while he was there, um, he happened to look at the food that was being delivered to his unit. Now, the way the French deliver food is they don't have it boxed up like we do at the grocery store. They were used to going to the farmer's market with their bushel baskets and bringing home the food in bushel baskets. And so it turned out that in his radar unit, their food was delivered in bushel baskets, and it was put at the base or the bottom of the radar antenna. Radar antenna is pretty high. And but anyway, Anton Prior noticed over time that the food didn't go bad. Now, he had, all of his life, his family had gotten food from the farmer's market, and he knew that if you didn't eat it very quickly, it would start to go bad. But he didn't see any sign of deterioration in the food. And so that was curious to him. And then one day he went to an infantry unit a few miles away, and while he was visiting there, he went to look at their food supply, and it was going bad, a lot of it bad. And so he told the people who ran it, he says, you should get your food from where we get ours at the radar unit, because ours doesn't go bad. And they told him, that's not possible. They said, we already get our food from the same place your radar unit gets it. We have only one supplier for our food. And then Anton Prior realized, oh, there may be something related to the environment that it's in. Maybe that antenna is doing something. So he went back to his radar unit, and he asked his commanding officer if he could move the bushel baskets of food about 100 yards away from the radar antenna and see if anything different happened. His commander said, yeah, if you find it starts to decay, then you better put it back, because we don't have any surplus of food. So anyway, he moved it away, and sure enough, it started going bad, just like the infantry unit food was going bad. So he moved it back, and it stopped decaying. After the war was over, Anton remembered that. He finished his medical school, he became a veterinarian, and he bought a surplus radar antenna, and he hired some electrical engineers to study it, to tell him what was happening to the food that didn't normally happen due to the antenna. And they told him there is two types of radiation coming off your antenna. Most of the radiation is transverse, and that's what the radar system uses. But there's a small amount of radiation that is longitudinal, and it's not intense enough to have an effect very far, but it is enough to cause that food to not decay. And they said, we can build you a bigger one, a better source of longitudinal radiation. So they did. And on the left-hand side and the right-hand side, you see the various parts of this unit. It filled a two-story building, and at the bottom you had this big gurney-like thing that they could put animals on. And first they practiced it with food, and it worked. It kept it from decaying. And then the concept that Anton Prior had in his head was that the cells were kind of like batteries. And when they run low on energy, they go bad. And the longitudinal light coming off the antenna, it recharges somehow the battery or the cell so it has more energy. And so that's what his concept was. So he said to himself, well, if that is the case, and I radiate a sick animal, and give their cells more energy, they might be able to overcome the disease. So he started doing that, and sure enough, he found over 90 diseases that people brought their pets and their farm animals to him to be treated, and he could treat them with this longitudinal light. He found there was a certain amount of frequency dependence from one disease to another, but the electrical engineers gave him the equipment so he could determine that, and he would record the frequencies for each of the diseases that seemed to work the best. And so that was the situation, and he's becoming very well known in Europe because he could cure diseases that no medical doctor, regular veterinarian, he was trained as a veterinarian, but he knew he couldn't get people, couldn't get these animals well from those diseases with regular pharmaceuticals. And so that was the situation. And then one of the men he had known in the military during World War II became the president of France. And while he was president, his wife became terminally ill with cancer, and they did radical surgery, radiotherapy, immunotherapy, all the major therapies for cancer, and she wasn't being helped at all. But he had heard and read in the newspapers that this man had cured animals with cancer. No pharmaceuticals, no medicines at all, just radiated them with his light, and they got well. So he came to him one day and said, I want you to radiate my wife. And the Anton Prior said, well, you know, I only have a license to do animals, and also I have not done any humans. I don't even know what the side effects might be, if there are any. And the man said, well, my wife's going to die in a week or two anyway, and we would like to take a chance because she might get well with your therapy. So he said, I will go get you a license and bring it tomorrow. So as the president of France, he went to the medical association. They gave him a license for this man who was a veterinarian to a human. And he radiated this man's wife, and within about 30 days, she was completely well of cancer due to this radiation. And he was very happy, and he announced to the world through all the major newspapers of Europe and the European Union. This was in the late 60s, early 70s. And he announced to the world that the French government was giving multiple $1 million grant to this doctor to start treating humans, because he considered humans more important than animals. And he said that this is a major breakthrough in medical science. It wasn't exactly new, because if you looked at the ancient pyramids of Egypt, they had pictures on the side showing various electrical therapies that they were using, but we forgot all about that over time. And so the pulse of life, as a result of his work and other people's work, is a longitudinal electrodynamic pulse in organic molecules. And organic molecules are like a slinky. You've probably seen a slinky, and you can have both transverse and longitudinal vibrations in the slinky, but it's the longitudinal ones that are related to light energy. And so if you absorb, if this molecule absorbs longitudinal radiation, it will gain more energy, and that will enable it to perform its functions better. And all organic molecules, when they die, they decay by giving off longitudinal radiation and follow the second law of thermodynamics. And consumption of food by organisms brings in a fresh supply longitudinal radiation that is in the food, longitudinal energy that's in the food, and that energy is being radiated off, and when you eat it, it goes into the cells of your body and into the blood, and that's how it gets delivered to all the different cells that you have. So, if we can summarize this, then this electrodynamic approach to life is based on the notion that there is a universal force law, so there couldn't be a separate law that controls life. It satisfies the second law of thermodynamics. It's based on non-equilibrium dynamics. It allows the growth of an organism from a single cell and aging to occur simultaneously. The longitudinal vibration of the molecular fibers in organic molecules is the pulse of life, and the frequency and rhythms of longitudinal vibrations control various life processes. Okay, now we can have some conversation, and we can talk about that, I guess. So, and I can't see anyone right at the moment.
All right, thank you, Bill.
Okay.
So the people who have questions for Bill, don't be shy. Well, I guess I'll start off with some questions. Let's see, we got some echoes going on here. But I think everyone else is muted. Okay, so Bill, so your final slide here says that what you've presented here is based on the universal force law, and you've shown us all kinds of interesting things like the acupuncture points. But what exactly would be the relationship between, say, the universal force law as you had described it? You had one slide full of equations, and things like the acupuncture points.
Well, the universal force law has certain symmetries. Those are the symmetries of all the molecules in a living system. No other symmetries exist.
So let's look at that. So how does your equations express that symmetry, or are they just also part of the 6 laws of electrodynamics that you base your force law on?
No, the symmetries are the chiral symmetry is based on the cross product in the empirical laws of electrodynamics, and so it's those cross products that create the various symmetries, particularly when you solve the 6 equations simultaneously together. So you see, not every one of the empirical laws has a cross product in it, but many do. And I write some people just write a sign of theta there instead of showing the cross product, but I put the cross products in so you can see that more easily. And so yeah, that's a peculiar feature, and so you have that type of symmetry, and you also have, for the solution, there are 2 solutions. There's one solution is the transverse radiation, and the other solution is longitudinal. Longitudinal is not normally put in any of the physics and electrodynamics books because they're following the version of Maxwell's equations solved by Oliver Heaviside, and he didn't know what to make of the longitudinal one, so he could work with the transverse, so he eliminated that from his solutions by.
Let's take. So you say that it's the cross product which is most involved in this symmetry thing.
Right.
So let's take the Lorentz force law, which is what I'm familiar with. So Lorentz force law says that you've got a cross product between the force and the test electrical charge in the magnetic field, which is often represented by, like, you know, the people holding their hands saying, if this is the electron motion and this is the magnetic field, you know, this your thumb is pointing in the direction of force. So I understand that, but what I don't quite understand is how does that lead to the symmetries that you're talking about? You know, you've got chirality. I mean, all this is saying that all these forces act at right angles to each other. So how does that lead to, say, you know, all the ear acupuncture points and things like that?
It doesn't specifically cover how many acupuncture points and where they are, but for instance, we just look at the structure of the body, take the human body. You have part of the symmetry, chiral symmetry, is left and right-handed. So we have a left and right ear, left and right eye, left and right nostril, the nose, left and right shoulders, arms, legs, feet, hands. You know, we got a lot of that, and you see a certain amount of that in our body symmetry. And we have two lungs. You know, we have quite a lot of things like that.
Yeah, we see all that symmetry. So Bill, my main question here that I'm not quite understanding is that you have showing on this screen here your derived universal electrodynamic force. You've got all those equations there. And all these other things you seem to be explaining about symmetry, you know, I'm having a hard time seeing what that has anything to do with those equations. It kind of looks like you've got the equations and then you're talking about something which is interesting and true, like, you know, all this stuff is very interesting about the symmetry, but I don't know that has anything to do with, say, Coulomb's force or Lorentz force law, or, you know, other Faraday's laws. Although I would certainly agree that life is certainly based on electrodynamics, because all life is based on molecules and atoms. And all molecules and atoms interact, obviously, through the electrodynamic force, right? So without the electrodynamic force, you could not form things like molecules. There would be no attraction or no basis of attraction. But you know, is that what you're saying? Is you're saying just, I mean, basically, you know, the universal force is the electrodynamic force, which is like the Coulomb force, which is the thing that holds all molecules together.
The Coulomb force is just 1/6 of the terms that represent the electromagnetic force. So you got to look at.
Yeah, that's like one of the electrodynamic forces that we recognize. You got the Coulomb force. You've got Lorentz force law.
But you see, those
you got three others
are independent of the others because they were used to explain specific phenomena, like. When I do the Lorentz force, I'm not trying to measure the Coulomb force. I'm measuring the effect of the Lorentz force. And so as far as the experimentalists knew, each of these force laws that they investigated was different and replied to different phenomena. But not all of the no one force law could explain all of them. You had to solve the whole set, the complete set, simultaneously, so that one solution could describe all the data that each of the 6 empirical laws had been invented to describe. And so that's how you got the more general solution. So the Coulomb law is very, you know, it's just a tiny part of electrodynamics. 1/6 of it.
Okay, so how about someone else? Say Harry. You certainly, but you may have a question about. You may have a question for for Bill. Do you believe that the universal force that he has is related to a lot of these phenomenon that Bill has presented?
I don't know because I'm not sure what the universal force is. The way you put the question is kind of, I don't know.
I think
Well, maybe just ask that. Try to get that clarified with Bill. I think that would be a fairly important question about what he's presenting, which is what is the universal force?
right. But the way to look at this, which I think is the only way we can, we don't know all the things that the universal force explains. But if you read most of your textbooks, they say, well, the forces in nature are the electromagnetic force, gravitational force, strong interaction force, and weak interaction force. Many parties will say that those are the four fundamental forces. Well, what I did is I showed that this improved version of electromagnetic force explains gravity better than any previous gravitational force, like general relativity theory or Newton's universal law of gravitation, and that the strong interaction force and weak interaction force are now known not to exist in matter, like the atomic nuclei. And so, as a result of that, we're left with only one force. Could there be more forces? Yes, there could. We just haven't discovered them. And but then the other possibility is that maybe it is the only force in nature. And then one would ask, well, if it's the only force, what other questions could it answer that we've never explored? And one of those is, well, maybe it can explain the nature and origin of life. But it may not. That's a chance you're taking. You want to see if it can. Well, by making detectors, and by the way, if you want to buy one of these detectors, it's called an experimental life energy meter, and it's for sale on the internet. And thousands of people have bought them and used them, and many hospitals do, and some doctors do. And so that's a possibility. So anyway, that's I think.
And there it is on eBay, $399.95. It can be yours.
Yes.
You see that? Is that the one you're talking about?
I can't see. Did you put? There it is. That's it. Yes. That's one version. The first version, cell phone booth. Version was a little bit bigger than this, but we found out how to make them with modern electronics. And by the way, there is no wires attached to this, but you do have an electric meter. And if you bring your hand within a few feet of that little square that you see on the top of it, that's a detector. Within a few feet, it can detect the longitudinal radiation from your hand. And all kinds of experiments you can do. You can take a plant, put the meter up next to a leaf on the plant, and then have a person touch another leaf on the plant on the far side, and the meter will jump as soon as you touch it, because all the light energy going into the plant is now registering on the meter. And if you pull a leaf off of a plant and put it on there, and just make a plot of the life energy as a function of time, and there's a way to put a gadget on there to do that, then you'll see that the life energy decays over time. So we're pretty sure we're measuring life energy and that sort of thing. And by the way, that is manufactured in Canada, because the Food and Drug Administration goes after anyone who manufactures it in the United States and bankrupts them, because the pharmaceutical industry and the medical industry does not want people to do that. I speak often at farmers markets where they sell natural foods that have not been genetically modified, and no things to keep the bugs from eating it have been put on the food, and so that would harm it. And anyway, with that food, this is called organic food. If you measure, let's say I have 2 Macintosh apples, same size, and one is regular farmer's version and one is organically grown, and you measure them and you find that the life energy in the organic grown one is higher than your life energy, and the life energy of the non-organic grown one is lower than your life energy. And then you say, oh, well, what happens if I eat one with a lower life energy? Your life energy declines until the effect of that food is gone from your body. And if you eat one with a higher life energy, life energy goes up.
Bill, this would be more convincing if you showed a schematic of the meter and explained how the detector works. Without knowing that, I mean, I just
have another talk that covers that.
I need to see a schematic and I need to see how the thing works.
I do have.
You know, I'm an electrical engineer. I got to see all the details.
Yeah, I do have that, but I don't know if we have time for that today, but we could do that.
Well, I'd certainly like to see that.
Search for that. I was looking for the this actual circuit diagram for this orgone energy detector here on the internet. You know, they have everything on the internet. I don't think I quite found it.
Bill, if you have that, could you share it in email?
Yeah, I could send it out to this group that comes to meetings. What's that?
Now, this reference here that says that the mechanical principles, it says since orgone let's see here, that's generators. I don't know about generators. We're looking for detectors here.
Okay. Now, what you're looking at here is different, but the orgone energy was done first by a doctor that worked with Freud. And Freud did not like the electromagnetic approach to life. So he broke up with this fellow and he moved to the United States from Europe and settled in Boston. And if you look up orgone energy and detectors and stuff like that, you'll find some of his work. The medical profession did not like his being here because he was curing people of disease with no medicine at all. And I don't can't put my hand on where that is, but I have so many PowerPoint presentations that I've made, hundreds. They are not all in the same place, unfortunately. Hard to find it. William Reich is his name, and he developed the first field meter, orgone life energy field meter, and I have a whole presentation on his work, but I can't find it right at the moment. Maybe if you give me a few minutes.
So the clue on this website is saying that William Reich developed the life energy field meter using high voltage induction coils to excite a large detector plate, and was able to show the existence and quantity of life energy charge in people, plants, and various objects.
Right.
Experimental life energy field meter uses a similar principle, but with modern solid-state circuitry and much lower voltages, which eliminate the need for bulky induction coils as used in Reich's original apparatus. So it has something to do with induction coils.
Well, what it is the only way we know to detect this life energy is in a capacitor. Capacitor is the only device that where you can detect this presence. And so the one that Reich made, the capacitor was the size of a telephone booth. Now we've shrunk it down so it fits in a handheld device. But we have a lot of solid state stuff that helps us do that. And if you go to the website for the Oregon Field Energy, there's all kinds of videos and everything showing how it works and diagrams and all that kind of stuff.
But even when you've detected the radiation, how can you demonstrate that it's longitudinal rather than transverse?
Because, first of all, it doesn't require a wire. You can shine a laser or any other kind of light on the detector and it reads 0. And there are only 2 known forms of electromagnetic radiation, longitudinal and transverse. So, and you can make a source of transverse radiation, and that's what one of the things that Reich did is he made a source and he used that to radiate people, and that caused them to get well. And this was before Anton Prior did it. And Anton Prior made such an impact on the world. You're probably familiar with the Star Trek movies, Star Wars movies. They were science fiction movies, and they tried to show off the technologies that were being developed at the time that movie came out. And the first one, and they showed 2 types of technologies in the first series. One was what was called the communicator, which we now know as the cell phone, but there were no cell phones in those days. And the second thing was called the tricorder, and the tricorder was based on the work of William Reich and also Anton Prior, and it uses longitudinal radiation.
So what would a generator look like or be composed of? I mean, if you put something in the proximity of a radar installation, as you said earlier, you're really putting it in the proximity of a magnetron, which is producing microwaves, which are basically not longitudinal.
So in the case like you could, as you say, there's a lot of things coming out of the radar unit. If you bring one of these up close to a radar unit, it will start reading. When you're reading, even as far away as 100 feet, you can still read something. But some of these things, like these Oregon energy pyramids and stuff, I don't know. I think those may be fake, but I don't know for sure. I've never gotten one. But so Oregon energy is kind of mysterious because the Reich never understood that it was longitudinal radiation. He was not trained in that way, and but Anton Prior learned a lot about that. And by the way, Reich, because he was healing people without using any medicine, he was gone after by the Food and Drug Administration and arrested and put in jail and died there after so many years because they never wanted him to practice any more medicine without using pharmaceuticals and other traditional medical procedures. There's someone you can see they get a reading even when their hand's not even touching it. And
incidentally, just comparing your approach with Schrodinger's very very briefly here, you appear to be saying that the electrodynamic force is the
light bulb
key.
glow whenever a living Oregon field approached the upper plate. Experimental like
these are very interesting movies, videos here, and they're all on one website.
device, induction coil.
So Harry, I'm showing this is the apparent circuit diagram for the life energy meter here.
Now this is the one by William Reich. It's big as the telephone booth, but yeah, that's it. And we've shrunk it down to the size of a cell phone.
So it looks like we can see there's that capacitor there.
Yeah.
And then there's this induction coil, and it says a diathermy machine, whatever that is. Seems rather simple. And so they just measure the output here.
Yeah, this is a light
between
bulb, by the way. That's
a light bulb.
so
This
big,
early one.
power to turn a light bulb. And the light bulb didn't measure how much it did. It just measured that you had light energy. It didn't tell you, I guess the light bulb was a little brighter when you have more, but it wasn't. It didn't have a meter on it. It was just a bulb. So we've come a long way.
So what do you think of that, Harry?
And this device, the handheld version,
It doesn't tell me anything that I mean, it's all got a diathermy machine, whatever the heck that is.
well, this is very crude, but that you see here.
So it tells me it's a diathermy machine. That tells me that it's generating an RF signal. And I'm assuming that's what they mean by diathermy machine. I don't know that diathermy machines are used much anymore.
Yeah, now see, this was done at a time when Reich was a doctor, a medical doctor from Europe, and so this was something he was familiar with that they used in hospitals and some other places like that. And he was just using the type of equipment that they had and modifying it to do what he thought he could do.
Well,
connected to a series of metal plates with a light bulb in between.
A diathermy is a thing?
it generates an RF signal. As I recall, it used to be somewhere in the range of 20 megahertz to 30 megahertz. Yeah. High frequency electromagnetic currents.
Yeah.
And it used to be, I don't know that it's used anymore. I don't know that much about it. I know that back in the old days of when I was during the 60s, and people would say the ham radio, they get interference on the ham radio, they'd say, oh, that must be the diathermy machine from the hospital down the street. We have a hospital down the street.
Yeah, yeah. I would say that's probably correct. And but because of his background, being a medical doctor working with Freud, he was also working with people that had psychological problems, and so he's coming from a lot of different points of view. And
well, I'll make a couple of comments here on your I know that this number of the things that you said go back. The idea of using a magnet or magnetism to cure disease is quite old. It goes back, to the ancient Greeks and that sort of thing. So that's pretty old, and people are still kind of messing around with that idea. So I suppose I'm sure you're aware of this.
oh yeah.
Magnetic therapy has been around since the Middle Ages, as I understand it, and before.
Oh yeah, but
people were told, that if they were asleep with magnets, magnetic stones, not the kind of magnet that we know, but stones with magnetic properties of magnetite, basically.
Right.
You cure diseases, et cetera, et cetera.
So this meter, the modern version of the old meters, it enables you to do all kinds of experiments. And on this site that this is coming from, this is a YouTube video, but on the website where they sell the meter, they have all kinds of videos showing you the type of experiments they've done with them, and you can actually see them doing it in front of you. And they also have the ability to put a little gadget on here which will enable you to connect this to your computer and to record what is happening. And so, for instance, you can measure the life energy of a yeast, what do you call it? You know, when you add water to yeast, it starts to grow until it uses up all of its food and then it dies. Well, you can actually plot the life energy of the yeast culture as a function of time, and you can see it as it starts to eat the food. It rises, and then it eats up all the food, and then it goes down and back to zero again. And you can actually measure that kind of thing. You can do all kinds of experiments with this type of meter. And I have one, and I've done quite a few of them myself. And it's very interesting. I also measure the life energy of various foods. I can just put an apple, an orange, whatever you want there. And as I say, I speak at farmers markets, and I show them the difference in organically grown food versus the non-organically grown food. And then when you measure your, after I show what the readings are on a big screen at the farmers market, I then have people come up and put their hand next to it and measure their own life energy so they can see how it compares with those. And I tell them that they don't get their life energy from chemical processes in the food. They get it from this radiation that's given off by the molecule. And
Bill, this is Bob Gray.
yes.
How do you shield or compensate for the friendly effect? Now, the friendly effect is something that I learned when I was in graduate school doing some experiments, and we was using an oscilloscope, and the professor said, look, as I approach our device, the frequency is changing, and if I wave my hand at it in a friendly way, the frequency is shifting back and forth. That's because of the change in the capacitance of the system that we were using that we hooked up to the oscilloscope. So how do you compensate in this device for this friendly effect, or simply a change in the capacitance of the overall system?
Well, first of all, the type experiment you're talking about involve wires and transmission of that sort of thing. Here we don't have that. Here, everything is done just through the air.
Right, but you still have a capacitance, and if you move anything around, then the environment that it's in is changing, so the whole capacitance of the environment that it's in is changing, which will potentially change readings depending on the device, etc. And so I'm wondering if you compensate for that in any particular way.
Yeah, you have to zero your device, and it should give a steady reading. So if something is interfering, like if I walk by the thing of an experiment, I might find it goes up and down a little bit. And here's a plant, and you can see the reading goes up as he brings his hand over next to the plant, and the one leaf of the plant is on the meter, and so you see that sort of thing. But yeah, you have to, like any other experiment, you have to take into account all the effects that you see. And
well, I mean, you know, it's to your question. I mean, obviously, it's a capacitance type of capacitance meter that's being used here.
Right.
So
capacitance meters can measure life energy.
So the question is, I mean, the experiment I would like to see is for you to take a vial of, like, say, living seeds and measure it, and then take those seeds, throw them in a microwave to absolutely kill everything in it, but not change the chemical composition or structure any, and then measure that, and does that register less life energy? You know, take something which is clearly alive,
yeah,
and 2 vials of something which is clearly alive, measure one, kill one of the vials, and then measure it again, you get a different reading?
Yeah. And the other thing you can do is pull a leaf off of a living plant, and you'll have a high life energy reading. And just in a day or so, it'll go down to much less. And we just put it there, connected to our computer. We have a way of connecting the meter to a computer, and you can just get a graph, like a PowerPoint graph, and it shows how it changes over time. And I have presentations that do that. You can see the chart.
You change the water content of the material, you change the permittivity, and basically the capacitance is measuring the permittivity of surrounding
but permittivity is not involved because I don't have to actually touch anything on the meter. I just put it above the meter.
You don't have to touch the plates of a capacitor to change the permittivity of what's between the capacitor.
Right, but I don't touch the plates of the capacitor. Now, it's true that Wright did. You touched it because he needed maximum power to turn his light on. We don't need that much to run the meter.
So basically, you just use the return path as your ground and an electric plate as your other plate, and you have anything between the ground and that plate. You're measuring the permittivity of it. Anything like it's a friendly effect, like Bob says. Anything that gets in that range, in that area, it's going to change the permittivity between those two plates.
Right. But now think about this. I'm going up to a radar antenna. I can start measuring this, and as I approach, it gets higher and higher, and many different things. You can also do the yeast, like you see this little container of yeast here, and the food above it. That is, you see the meter rising as it eats more and more of the food, and then when it gets up to all that it can eat and it starts to decay, then and there's the recipe for how to make it. Then it will
composition of the material.
But that's not particularly convincing because obviously the contents of that bio is changing in physical dimension, and that would obviously change the capacitance.
Yeah, well,
what would be convincing is if you took that and then just immediately stuck it in a microwave after it finished growing, so that it didn't change in any form other than the yeast is dead, and then put it back in the meter, and it's zero.
You'll get the same result. You get the same.
Well, I don't know. I'd have to see that because I didn't see that in this experiment.
Life energy goes down to zero.
You can't do that because you've changed.
Well, they didn't show that in this experiment. That would be the convincing thing.
No, in that particular one. But you can do your own experiments, and I do them all the time at my house.
Well, I would suggest you do that experiment. Post us a YouTube video where you grow the yeast, then as soon as it's showing that it's got lots of life energy, then immediately kill the yeast by whatever means you have very quickly, and then put it back on and show that the life energy has gone to zero. The leaf one is not convincing because that change could happen just because of evaporation, right?
No, the bottle is closed.
I mean with the leaf one. If you just leave a leaf out, it's like, it's going to change.
The yeast one goes down to zero also over time. Because when it runs...
I'd have to see that. I'd have to see you... see, the problem is that yeast in that experiment physically changes the arrangement of the molecules that are in that jar because it goes from, it expands, so it's clearly different. And that would clearly affect, that would definitely have a impact on just capacitance. So you got to have a really good experiment that shows that what you have is exactly identical except for life versus no life. That's what would be convincing.
Well,
as a scientific experiment.
As you know from making bread, when you cook it, you get a different product than when it was just yeast growing. So you may have some other chemical reactions that occur. So.
But there are just tons of videos on this Oregon energy here. I'm just almost inexhaustible supply.
Yeah. Now, a lot of the crystals and stuff that are shown there, I've never done any experiments with them, so I can't vouch for them particularly. However, if you go to these new smart meters that people put on their house, electrical, and you measure the light energy coming on, you'll see that they have a devastating effect on light energy. So this is not a small topic. I mean, you just see, look at all of the websites that talk about this stuff, and many countries, like particularly in Africa, they put a lot of stock in these crystals, uh, and they sell them to the rest of the world. And but the point that I was trying to make is that it's this second form of the electromagnetic field, the longitudinal waves or longitudinal fields, that by the way, the properties of longitudinal fields are different from the properties of the transverse fields. And when you measure them,
the longitudinal field
super did, you can measure
longitudinal field
14
can't be
properties of
insulated.
fields, and you see that they're different from any other field, electromagnetic field.
Longitudinal, is that correct, Bill?
Pardon?
The longitudinal field cannot be insulated against.
I think that may be true. I haven't looked at it.
I'm sure that's what you said before, and because the longitudinal field is nothing more than an increase or decrease in the charge, the volumetric charge of a region. Volumetric charge of a region cannot be insulated against. You can surround it by metal, you can surround it by plastic. Charge still makes its way through because of the dielectric characteristic of any material. So the longitudinal wave you're talking about is simply an increase or decrease in the volumetric content of a charge within a region, and that is also symmetrically. Any charge would be symmetrically spherical in its characteristic of radiation in the absence of a magnetic field. So that symmetrically spherical increase or decrease in charge would in fact give you a longitudinal wavefront which was spherical.
That sounds good.
So actually, I don't, in my view, that's not really a electromagnetic component as much as it is a gravitational component, because there is no, because if you move it linearly, it doesn't produce a magnetic field.
Well,
Move an
I feel
electromagnetic
that
component linearly, it produces
what I
a
did on
magnetic field.
gravity is showing that
Longitudinal.
gravity is electromagnetic in origin, because we get the best version of gravity we've ever had, and we simplify modern science so much. And I haven't talked about this to you all, but I have also a theory of elementary particles, in which I show the electromagnetic structure and decay and all the properties of various elementary particles. And this, as you know, there's over 100 elementary particles. And so
I think within your universal force, the thing that's missing in the Maxwell's equations is the mass component of the particles. Mass component content is
well, in electrodynamics, you might say that because it doesn't deal with mass. But when you derive the force of gravity and the force of inertia is F equals ma, then the coefficient of the acceleration term is what we would call mass. And you find out when you derive it as the force between a charge and a vibrating electric multiple. You discover what that is, and so you get a term, and it has to do with the amplitude and the frequency of the vibrating dipole, for instance.
it can be simulated that way. The true gravitational field, you'll be able to simulate that way. But basically what you're doing with your universal force is you're combining the electromagnetic with the gravitational and so it comes down to a single force responsible for both characteristics, correct?
No, we're showing that the force of gravity is a very tiny electromagnetic force. It's 10 to the minus 40th power as strong as the Coulomb force. And so when you see that, you realize, oh, you know, when we were doing electrodynamics, we never noticed that because it's so weak in comparison. We only noticed it when we're not doing anything related to electrodynamics. But when you solve all the 6 empirical equations of electrodynamics, and now your new electromagnetic force, which got more terms than traditionally done with Maxwell's equations, then you see that it can predict the force of gravity. And chemists are the ones who really pushed this, and they wrote down the formulas and everything for that. And so I can't claim the original.
I think the force of gravity can be proportionally measured based on electromagnetics because gravity is basically the bulk or deformation of space, which includes both electrical and mass components. So wherever you have mass components, you typically have a matching amount, a comparable amount. Oh, I think I lost. Did I get lost here?
No, you're still here.
Okay, anyway, because they are a balanced proportion, then wherever you find a certain amount of electromagnetic characteristic, you're going to find an equivalent amount of mass characteristic. So you can certainly say that if electromagnetic characteristic increases, mass characteristic increases. But if you look at strictly mass characteristic of a neutral particle, then you accelerate that neutral particle, you get no electromagnetic characteristics. Whereas if you accelerate electromagnetic charge like an electromagnetic particle, then you do get a magnetic field emanating from it. That would be the difference between a gravitational characteristic and an electromagnetic characteristic. So I wouldn't call a longitudinal wave an electromagnetic wave because it's simply symmetric. But basically, I think our concepts here are the same. It's just a matter of terminology.
Well,
you also mentioned that the speed of transmission was greater than that of conventional transverse waves. I'm wondering typically what you would estimate this to be. Would it be a number of times greater, or would it be orders of magnitude greater?
If you look at the resulting equations of electrodynamics after you solve them all simultaneously, the terms that describe the longitudinal fields and radiation have no factor of c in them. So it looks like the velocity is infinite.
I got about the same thing, Bill, in my determination. The only difference in my determination would be that the velocity at a distance from mass increases greatly, and as you approach mass, the velocity decreases. And so in other words, the wavelengths would shorten as you approach mass and lengthen as you go away from mass. But eventually, the velocity, like yours, does become infinite.
Yeah, I haven't noticed any terms in the work I've done that would slow down the velocity, but you would think that if it's absorbed and re-emitted, it's going to have some effect, and I don't know the time of that. And but the gravity decays, and what we find is that the decay rate of the mass, kind of like a sphere of mass, depends on the size of the mass and the fact that the radiation that is emitted is reabsorbed if it's still inside, but if it's on the surface, it can escape that body. And so there is a lot going on there, and I, you know, there's I haven't investigated everything. I've got so many topics, as you can see, to try and investigate. And but the one on life I felt like was useful. And just like that, also, if the theory of elementary particles is all based on electrodynamics, which I think it is, then you should be able to do a better job than the standard model of elementary particles, which involves 19 to 29 adjustable constants representing unknown physics. And in the case of electrodynamics, you have just electrodynamics, no other forces, and it seems to do a better job of explaining all the verifiable data that we've been able to collect in scattering experiments and accelerators and that sort of thing. And so I've worked in those facilities and I know a little bit about that, but I like the fact that you have such a simple explanation that's not so complicated that you have to have all these adjustable parameters representing effects that are somewhat dubious as to what it is.
Just getting back to this business of speed for a second, you mentioned infinite speed, which doesn't seem very satisfactory. I mean, excuse me, when you measure the apparent speed of interaction of, say, gravitational forces, or perhaps the speed of an electrostatic field, how quickly that is taken up at a distant point, it appears to be maybe at least 10 to the power of 20 times the speed of light, something like that. It's not infinite, but it's a very large number.
Right.
So might that not also be the case with longitudinal waves?
Well, there could be these secondary effects on longitudinal, like absorption and readmission and all kinds of things going on. I haven't investigated that. I'm just saying that the equation, the simple equation that we get from the fundamental empirical equations of electrodynamics, they don't take into account all these effects. And we need to perhaps find a way to incorporate those in them, and then we would have a better way. But it's people have noticed that the force of gravity has to be faster than c, or it doesn't. You can't explain the data that we measure in our solar system, and so we know it's faster than c, but we don't know why it's faster than c, and in my case, the longitudinal radiation, by the way, doesn't produce gravity directly. Gravity is really a electromagnetic phenomenon, but you have the problem that the tensile strength of the electromagnetic field keeps everything connected and in phase. And we don't know exactly all the details of that, but we need to know more, I think, over time.
All right. Well, we're getting towards the end of our time here. So thanks, Phil, for coming up with a presentation today on the electrodynamic origin of life. I know that I had announced a gravity topic, but I was glad to see that you have a topic for us. And if anybody else has a topic they would like to present, then I welcome that. And I'll just keep my my little gravity discussion until next time. But to kind of summarize, so Bill, you're talking about the electrodynamic origin of life, and you have your formulation of the universal force, which is a simultaneous solution of the 6 other known equations of electrodynamics. And you showed us various interesting things about how there are various pathways in the body, and things like there's acupuncture points and pressure points on your hands and on your ears. And you mentioned the the symmetry that you get, symmetry of say DNA and symmetry of like lots of other things which are in spiral format. And we also discussed the energy life meter, and we saw that you can buy that on eBay, and we discussed the various videos that are shown on there. And like I said, I would like to see some more convincing experiments, which basically the only variable in the experiment would be living versus dead, to see whether you're merely measuring just the capacitance of the material, which shouldn't change with living or non-living. And we also discussed this topic of the longitudinal wave, which is theoretically what this meter is measuring. And my only comments on that is that I think that it's probably not correct. My own personal opinion on this is that there is a universal force. That force is the Coulomb electrostatic force. So your approach has been to simultaneously solve the 6 equations of electrodynamics. I would argue that what you need to do instead is to find the actual universal force, which I believe is just the electrostatic Coulomb force, and then derive all the other 6 other empirical equations based off of that. Now, I haven't done that, but I'm just feeling that is, probably a different approach that may need to be considered. So, but once again, that's my little opinion. So, thanks, Bill, for having your presentation. And I believe that will do it for this week's episode of the John Chappell Natural Philosophy Society.